Okay, so let's see some questions based on the topic sound. We have discussed the concepts, now it's time to discuss some of the questions. Okay, so the first question that we have to discuss is, a sound wave has a frequency of 2 kilohertz and the wavelength 35 centimeters. How long will it take to travel 1.5 kilometers? Okay, so question says that there is a sound wave. Question number 1, it says that there is a sound wave which has a frequency, okay, f, or we can write it by v, frequency as 2 kilohertz, which is 2000 hertz, okay, and it has a wavelength lambda of 35 centimeters, which is 0.35 meters. Okay, now we need to calculate that what is the time required by this wave to travel 1.5 kilometers. So it means we have to calculate that the time period, and we are given with the distance, that at how much time will it be required. So if the distance is given and we have to calculate the time, what is the basic thing that we require? We need the speed, we need the velocity or the speed, whatever you can say. So here we will see that we know a formula to calculate the velocity, and that formula is speed is equals to wavelength times frequency. The wavelength time frequency, that is v, is equals to wavelength is lambda into frequency. Frequency is denoted by this nu. Okay, so lambda is basically 0.35 into what is nu, it is 2000. So when you solve this, 35 is 270, okay, and we have 2 zeros and 2 decimals, so one more 0, meters per second. So 700 meters per second would be the velocity of this object, velocity of this sound wave. Now if it wants to travel 1.5 kilometers, so time taken to travel 1.5 kilometers will be equals to distance upon speed. Okay, distance is 15, 0 and 0 upon speed is 700 seconds. So we can divide this, it is 2.1 and 4 seconds. Okay, 2.14 seconds would be the time required by this wave to travel 1.5 kilometers of distance. Okay, so this was the first question. Now moving to the second one, question number 2. Question number 2 says, calculate the wavelength of a sound wave whose frequency is 220 hertz and the speed is 440 meters per second in a given medium. Okay, so in this question we are given with the frequency as 220 hertz, okay, and the speed of the sound wave, that is v, is 440 meters per second, and our task is to calculate the lambda. So again we know the formula, that is velocity or the speed is equals to wavelength into frequency. Now velocity is 440 is equals to wavelength is lambda and frequency is 220. So we can see that we can divide this. So lambda will become 440 divided by 220, that is 2 meters. Okay, so the lambda, this is 220 and this 400, yeah. So the lambda will become 2 meters. So see, this is a very basic question. At this level, at this point of time in your class 9, only this basic questions would be interesting, would be covered in the syllabus, but we do not know. Okay, let's see the third question. Question number 3. It says, a person is listening to a tone of 500 hertz sitting at a distance of 450 meters from the source of the sound. What is the time interval between the successive compressions from the source? So it says that a person is listening to a tone which has a frequency of 500 hertz and the distance of person from source is given as 450 meters. Now what is our task? We need to calculate the time interval between the two successive compressions. The time interval between the two successive compressions. So we have to find time interval, okay, between two successive compressions. Now as we have seen that the sound wave travels in this format, this is the compression, then rarefaction, then compression, then rarefaction, then compression, then rarefaction. So it do not matter that whether this person is sitting at 450 meter or some 4500 meters or any distance, means the distance of the person from the source will not going to matter. What is important here is the time interval between two successive compressions will be equal to the time period. Okay, it will simply be equal to the time period of the sound wave. So how we calculate the time period? Time period T is equals to 1 upon the frequency. Frequency is 500, so it is 500 hertz. So this comes out to be, this will become 0.02 seconds. Okay, this will come out to be, this is 0.002 seconds. 1 by 500, that is 0.002 seconds. This would be the time period between the two successive compressions, or you can say the two successive rarefactions. It's simple, because one rarefaction and one compression combine to form a time period, and this would be for another time period. So that's why if there is a compression at this point, then after exactly the time period, after the interval of the time period, we will see another compression, and after again we will see one more time period, after we will see one more compression. So the same thing will be applied to the rarefactions as well. The two successive rarefactions will be at a distance of time period, okay, or at the interval of time period. So whether in this question it would have asked what is the what we can say, what is the question? It says the time interval. What is the time interval between the two successive compressions? That would also be 0.002 seconds. And if it would have asked the time interval between the two successive rarefactions, okay, then also we will see the time period would be 0.002, okay, the time interval would be 0.002 seconds. Okay, so this completes the third one. Please note this. Okay, now let's see the question number 4. It says a person clapped his hands near a cliff and heard the echo after 5 seconds. Then what is the distance of the cliff from the person if the speed of the sound V is taken as 346 meters per second? Okay, so question says that a person has clapped near the hill, and what happened? He heard basically the echo after 5 seconds once he clapped. So we need to find out at what distance the hill is located. See what will happen. The situation here would be, if this is the hill, let us say I am considering the hill as a vertical hill, and here is the person. So the person, when he clapped, what happens? The sound move to the hill, it get reflected from the hill and will come back to the person, and the person can hear. So in 5 seconds, if I assume that the distance between the person and the hill is d, then the sound has travelled d distance to reach the hill and rebound back again d distance to reach the ear of this person. So what we can see, the total distance travelled by the sound is, two-d, okay, d plus d, okay, and the time taken by sound is 5 seconds, and the speed of the sound. The speed of sound is given as 346 meters per second. 346 meters per second. So we can say that speed is equals to distance upon time, that is distance is equals to speed into time. Now distance is equals to speed. Now distance, in place of distance I can write 2d is equals to speed. Speed is basically, we can say 346 into time is 5 seconds. So I can solve this 2 times, this 2 1 and 2 7 and 3. So d will become 173 into 5, that is 500 plus 7, this is 350 and 12, sorry 15. So this will come out to be 865 meters. So d will be 865 meters. This is the distance travelled by the sound. So this was question number 4. Now let's move to the question number 5. It says an echo returned in 3 seconds. What is the distance of the reflecting surface from the source given the speed of sound is 342? See, again the question is similar to question number 4. It says an echo returns in 3 seconds. So the time for which the sound travels is 3 seconds. The velocity with which the sound travels is, the speed with which it travels is 342 meters per second. Okay, and we have to find the distance of the reflecting surface from the source. Okay, so let us say this is the source and this is the reflecting surface R. So we can see that if this distance between them is d, then the sound will go to the reflecting surface and travel a distance d and will come back again by travelling a distance d to the source. So we can see that total distance travelled is 2 times of d. So we can say that 2 times of d distance is equals to speed into time. Speed is 342 into time is 3. So we can see that distance will come out to be, this is 2 1s are 2, 2 7s are 14 and 2 1s are 2. So d will be 300 plus 210 plus 3, that is, you can add them, this is 513 meters. So this is the distance travelled by the sound in the case of echo, because echo is simple, it says from the source it goes to the wall and gets reflected and come back to the person. Okay, in this way echo is happening. So we can simply write out that distance between source and reflecting surface is d. So the sound has travelled basically 2d distance, it has to travel twice. Okay, the first is it will go and in the return. Okay, so this is question number 5. Now moving to the question number 6, it says a ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. If the speed of the ultrasound through the seawater is 1531 meters per second, then what is the distance of the seabed from the ship? See, it's related to the sonar. We can see in the question number 6, consider this as the seabed. Okay, consider this as the seabed and this is the water. At the surface of the water we have the ship which is sending out the signal. So what will happen? The ship will send out the signal which gets reflected from the seabed and return to the ship in this way. So if I assume that the distance between the ship and the seabed is d, we can see that the distance travelled by sound is d, first from ship to the seabed and then the seabed to the ship is again distance d. So total distance travelled by sound is, total distance is equals to 2d. This is the sound, this is the distance travelled by the sound, and we can see the speed of the sound is given as, 1531 meters per second and the time of detection is 3.42 seconds. So we can simply write that distance is equals to speed into time, that is 2d is equals to 1531 into 3.42. So the distance will come out to be 1531 into 3.42 upon 2 meters, and when you solve this, this will come out to be 2.62 kilometers. Okay, this is just a basic solving you have to do. You have to calculate the value and you will get the answer. Okay, so we have solved the question number 6. Now moving to the 7th one, it says a submarine emits a sonar pulse which returns from an underwater cliff in 1.02 seconds. If the speed of the sound in salt water is 1531 meters per second, how far away is the cliff? Okay, so question number 7, it says inside the water there is a cliff, okay, and this is the surface of the water, and here we have the sonar. So this sonar is basically sending signal inside the cliff, inside the water, and it gets rebound back, it gets reflected from the cliff. Okay, it gets reflected from this cliff. What we can see that if the distance between the sonar and the cliff is d, the distance travelled by sound is distance travelled by sound, it will be equals to 2 times of d, because it will come to the cliff and gets reflected and return to the sonar. It is 2 times of d, and what is given, the time taken is 1.02 seconds. 1.02 seconds is the time taken, and the speed of sound is given as 1531 meters per second. So how far is the cliff? So we have to calculate the distance. So now distance is equals to speed into time. Distance is 2d, speed is 1531 into time period is 1.02. Okay, this is how we need to see, and this will come out to be d is equals to 1531 into, this is 1.02 upon 2. Okay, so 1531 into we can say that this is 0.5 and 1, 0.51, and when you multiply this, this will give you 780.31 meters. This is the distance of the cliff from the sonar. Okay, this is the distance of the cliff which is inside the water from the sonar. Okay, so this completes the question number 7. Okay, now moving to the question number 8, it says a person has a hearing range from 20 Hertz to 20,000 Hertz. What is the typical wavelength of the sound waves in air corresponding to these two frequencies? Take the speed of the sound as 344 meters per second. So we are given with the frequency range, that is humans can hear from 20 Hertz to 20,000 Hertz. Okay, and the speed with which the sound travels is 344 meters per second. We have to find out what is the range of wavelengths. Okay, what is the range of wavelength corresponding to this 20 Hertz and 20,000 Hertz. So we can see we have the formula that velocity or the speed is equals to wavelength into frequency. So to calculate the wavelength, I have to divide velocity by the frequency. So now we can see the velocity or the speed is 344 and the frequency is 20 Hertz. So the wavelength would be 344 upon 20 meters, and here we will have the speed as 344 upon 20,000 meters. Okay. So by calculating this, as we know that this frequency and wavelength are opposite to each other. More frequency means less wavelength, less frequency means more wavelength. So we can see the signal which is of 20 Hertz will going to have a higher wavelength compared to the signal which is of 20,000 Hertz. So we can see that we can solve this to 10 and this is 172. So this is 17.2 meters, and when you solve this one 172, this is 0.0172 meters. So the range of wavelength will be from 0.0172 meters to 17.2 meters. This is the range of wavelength which the humans can hear. Otherwise, the any sound or any wave which is below this wavelength cannot be heard, or above this wavelength. For example, if a wave has 20 meters of wavelength, So 20 meter wavelength cannot be heard by the humans. Okay. So this is how you have to solve the question number 8. Okay, now moving to the question number 9, it says a stone is dropped from the top of a tower 500 meter high into a pond of water at the base of the tower. When is the splash heard at the top? Okay, so it's a very interesting question. It has the application of multiple concepts. This is question number 9. See, let us say this is the pond. Okay, this is the pond at the base, and this is a tower of 500 meter height, and I am dropping a stone from this point. Now I want to see that if I drop a stone from this point, after how much time I will hear the splash. So at what point of time you will be able to hear the splash? Once this stone reaches the pond, okay, it gets dropped inside the pond. At that point of time, the sound wave will be generated, and the sound wave will reach to the top, and you will hear the sound wave. So here you can see that two things are involved. First is the time for stone to get to the pond. Let us say that is T1. T1 is, let us say, the time taken by stone to reach pond. Okay, because splash can be heard only after the stone reaches the pond. If the stone does not reach the pond, how can the splash happens? Okay, so that's why the time taken by stone to reach the pond is T1 time at this point from you when you have dropped this, and T2 time is the time taken by sound to reach the top. Okay, T2 is basically the time taken by sound to reach the top. So I dropped this stone from this, it will reach this pond in T1 time, and the splash will be heard at the top after T2 time. So the total time after which the splash can be heard will be T1 plus T2, the sum of these two times. So first I have to calculate that after how much time this stone will reach the ground. Okay, after how much time the stone will reach this ground, reach this pond. Okay, so to calculate that I have to apply S is equals to ut plus half at square. The equations of motion, remember the equations of motion we have to apply here. Distance will be 500. Now what is the initial velocity? We can see at the point when I am dropping the stone, its initial velocity is 0. So u into t will become 0 plus half into, now g, this a will be, acceleration would be equals to acceleration due to gravity, because it is a free fall. Okay, the stone is freely falling, so it is 10 into t square. Okay, so this will become 5, and this 5 will get cancelled here, 100. So the time will become 10 seconds. Now this is which time? This is the time taken by stone to reach the ground. So T1 time is equals to 10 seconds. Okay. Now as I have calculated the T1 time, I have to calculate the T2 time as well. In the T2 time, the sound has to travel a distance of 500 meters with the speed of sound. The speed of sound is 340. So the speed of sound is given as 340 meters per second. So we can see that the time T2 would be 500 upon 340. So these zeros will get cancelled. This is 17 and 25. So it is 25 by 17 seconds. This is the T2 time. So the total time after which the splash can be heard will be T is equals to T1 plus T2. T1 is 10 plus T2 is 25 by 17. So when you add this is 170 and this is 195 by 17 seconds. Okay. So the total time comes out to be 195 upon 17 seconds, after which the splash can be heard. If the question is like that, when the stone is dropped, from that point of time when the splash is heard, so you can calculate only this T2. but here it is saying that I am dropping a stone and after how much time I am able to hear the splash. So I have to take the time, I have to consider the time by which the stone will reaches the pond and the splash is made and heard at the top. Okay, both the things I have to consider. Okay, so this is the question number 9. Okay, so let's solve the question number 10. It says a sound wave travels at a speed of 339 meters per second. If its wavelength is 1.5 centimeters, what is the frequency of the wave? Will it be audible? See, it says a sound wave is traveling at a speed of 339 meters per second. If the wavelength, if its wavelength is 1.5 centimeters, so see, we are given with two things. The first thing is the speed of sound. The speed of sound is 339 meters per second, and another thing is given as the wavelength of the sound as 1.5 centimeters. Now we need to find out its frequency and we need to confirm that whether this frequency is audible or not. So what you can see here, we can apply the concept that velocity or the speed is equals to wavelength into frequency. The velocity we are given with 339 is equals to, this is frequency, wavelength is 1.5 and I will divide it by 100 and this is the frequency. To convert it into meters, this is 1.5 by 100 meters. Okay, you can write it in the form of 10 to the power. So 339 into, this will become 1000 upon 15. This will be the frequency. So what you can see, when you solve out this particular step, you will get the frequency V as equals to, it is 22600 Hertz. Okay, you will find the frequency comes out to be 22600 Hertz. Now, will this frequency be audible to us? Will I am able to hear this frequency? What is the audible range? We know the audible range is 20 Hertz to 20,000 Hertz. But this frequency is 22,600 Hertz. So I will say this frequency is not audible. This frequency is not audible to me. Okay, I cannot hear this frequency because it is out of my range. Okay, so this completes the question number 10.